Hello, good morning everyone. We are Project MindGuard, an AI-powered mental health support app. Our group members are 4465 Disilva KGBP, 4478 Dharmatilka MDSK, 4486 Diluksha HLUN, 4671 Mantilka MMPL. Mental health is becoming one of the most significant global challenges. Yet, millions of people cannot access immediate emotional support when they need it most. MindGuard explores how artificial intelligence can provide fast, empathetic, and safe assistance while encouraging users to seek professional care when necessary. Let's move on to the slide 2. According to the World Health Organization, around 97 million people worldwide are affected by mental health disorders. In many low and mid-level income countries, nearly 75% of people receive no treatment, mainly because of limited mental health professionals. This creates gap where people often have no immediate emotional support during difficult moments. Our objective was not to replace psychologists or therapists, but to develop an AI system that acts as a first responder, providing emotional support until professional help is available. Let's move on to our co-pipeline part. MindGuard process every user message through three AI modules running simultaneously. First is perform emotional classifications to understand how the user is feeling. Next is check for possible crisis situations such as self-harm or suicidal intent. Finally, it generates an empathetic response tailored to the detect emotions while ensuring all safety guidance are followed. Since this is research prototype, every response includes safety disclaimers and recommended professional help whenever appropriate. Now, we would like to briefly demonstrate how MindGuard works. Uh, I will paste the message I have copied. I have been feeling hopeless recently. I don't think anyone understand me. And uh, check, analyze, and generate response. It will automatically generate this kind of a message. Here, the system first identify the user's emotions. At the same time, it checks whether the message indicate mental health crisis. Finally, it generates an empathetic response and automatically include professional support resource whenever necessary. The entire process happened within few seconds. Now, I'll hand over to our second member to explain the AI technologies behind MindGuard.
Thank you. MindGuard combines several modern AI techniques to provide accurate and empathetic responses. We first use natural language processing with TF-IDF memorization to capture the importance of words in user messages. Emotion recognition is performed using DistilBERT, a lightweight transformer model trained through transfer learning from BERT. To identify unusual patterns that may indicate crisis, we implemented the Variational Autoencoder or VAE. Finally, we use prompt engineering techniques including zero shot, few shot, and chain of thoughts prompting with Llama 3 to generate supportive responses. Our system follows a microservice architecture. The user sends a message through the interface FastAPI backend. The backend simultaneously routes the message to the emotion classification, crisis detection, and prompt builder service. Running these services in parallel reduces the response time while allowing each component to specialize in its own task. Their outputs are managed into final response with mandatory safety warnings and crisis resource recommendations. And now invite our third member to explain the implementation and results.
Thank you. MindGuard was developed using Python 3.1, PyTorch, Hugging Face Transformers, and FastAPI. To ensure code quality, we followed Web 8 coding standard and implement strict type checking and rough for linting, and also implementation through 52 automated tests. Our emotion classification model was trained using approximately 58,000 records from Google's Go Emotion dataset, and we achieved micro F1 score of 0.57 and macro F1 score of 0.416. Micro measures overall prediction performance, while macro evaluates performance equally across all emotion categories. And also, we evaluate different prompting strategies for generating empathetic responses. We compared zero shot, few shot, and chain of thought prompting using Llama 3. In addition, our backend applies strict safety rules that automatically include professional crisis resources whenever a high-risk situation is detected. Now I will hand over to our final representative.
One of our biggest challenge was crisis detection. Initially, we relied only on a variational autoencoder for anomaly detection. However, it achieved a recall of only 3.2 because crisis-related language often reassembles normal negative emotional conversations. And then the keyword detector performed better with around 35% recall, but neither approach alone was reliable enough. To solve this, we combined both methods using an OR gate strategy. If either the VAE or the keyword detector identifies a possible crisis, the system immediately activates the crisis support protocol. In mental health applications, missing someone who genuinely needs help is far more dangerous than producing occasional false alarm. MindGuard combines transformer models, generative AI, and defensive engineering to deliver safe and empathetic mental health support. So while it is only a research prototype and not a replacement for professional healthcare, it demonstrates how AI can bridge the gap between individuals in distress and professional mental health services. Our key philosophy is simple: AI should support human care, not replace it. And thank you very much for giving your attention for our project.